Hello everyone, this is my 15112 Dome project. My name is Harsh Varthankeria, and my project is essentially a solver that solves for fire escape times and simulations for buildings and things of that kind. So to start off, I would like to talk a little bit about the environment I'm using, which is a 3D modeling software called Rhinoceros 3D. Rhino is a very common 3D modeler for architects and especially used by architects to make 2D drawings and plans and sections of that kind. And what I wanted to do was use this native environment for architects as a space where architects could really quickly make their own plans and sections and drawings and test out whether or not it would be effective in a fire. So this is Rhinoceros 3D. It's a pretty simple 3D modeling software where you could make things such as rectangles and circles and things of that kind to represent columns and walls and whatnot. My software or my script runs within the environment, which is a plugin for Rhino called Grasshopper, which allows the architect to begin to script things into the Rhino environment, start to automate a few things, and that's exactly what I've done here. So right now I've already loaded up a pre-made plan of a museum type, for example, where you have walls and you have columns and you have these sort of dots which represent people moving around, as well as the yellow, which is supposed to be the exit or the fire escape, and the sort of green circles, which could, in this museum type, could especially be a sort of artwork or objects of interest. So to sort of dive into my script and how that works is essentially it is an agent-based system which uses object-oriented programming and KD trees to simulate humans moving around in space in the case of fires. Now, a few things that I've done is create an obstacle detection and collision algorithm that is true for humans. And so when you use typical Boyd algorithms, they tend to stick to walls and go through walls. But when humans move around, they actually use the vertices of objects and move around them, especially if it's a fire and they want to get around an obstacle, for example. So to jump into my solver, essentially what you can do is you can first sort of set rectangles and circles as a method to sort of generate walls and columns of that kind, and you can also set where your exit points are. You can have more than one exit. You can have I have two here. You can have four or five or how many of you want. So these are the walls that I have preset. I can set other separate walls if that's what we can do here. So set a wall there, set a wall there, one here, one right in front of the exit, and let's do one here. So this is updated to get me my new walls. Now I have two modes running in the solver. One is a general circulation mode, which is not related to a fire, and the other one is a fire mode, in which case people will head straight to the exit. So because in this case I'm simulating museum, my general circulation modes will have my agents move to each of the objects of interest before moving off to a entry or exit point. So to start my fire simulation, we can run that and see how that works, and then move on to the regular case, which is not a fire. So here essentially you set this toggle fire to true, and the reset is essentially a method to sort of start or stop the simulation. So the moment I set the reset to false, my simulation will begin. And as you can see, all these people are sort of moving around the obstacles and so forth to get to the end. So these obstacles sort of move around, these agents sort of move around the obstacles and go straight to the exit, or once they've gone to the exit, they disappear, which means they've gone to a lower floor and gone outside the building. Once the simulation is done and you can see all of the agents have stopped, you can set the toggle to false, to true, and it will save a text file that gives you certain stats on your building. So it automatically generates a text file showing the steps the agents have taken, and a step is essentially defined as a human step. It will show you the average steps taken, max steps, min steps, and so on and so forth. So in this way, you can actually, as an architect, redesign your building and see how your building can perform better. So you can set other rectangles and see if the steps or whatever else has improved or worsened in that case. So this will give you a good idea of how your building performs during a fire. Now, another few things that I have implemented is a system of recording the paths, and as you can see, the points are following a certain direction, and there are these sort of gray lines being generated, which are the paths followed by the people, which is what this is here. And this right here is what generates the analyses for the fire, which you can see is right there. And finally, I've implemented a text writer, which takes this analyses, and once everybody has left the building, it creates the text file. So setting the simulation back to false. Another last thing that my term project does is give you a general circulation for a museum or whatever kind of building you want to do. And so if I set my fire to false and I restart my simulation, now as you can see, my people move first towards these objects of interest or artworks in this museum case, and move around the obstacles to go and visit all the other artworks. And as you can see, it gives you some circulation paths in the museum and how people move around in this museum. If you zoom in, you can see that the human circulation is not just straight, because as humans we don't move in a straight line. We wiggle a little bit, so to speak, and sort of these small sort of visual features have been implemented to sort of make it look more lifelike and real. So this is my 15.112 term project. Thanks for watching.